we are discussing compound gear train. According to definition, in a compound gear train, each intermediate shaft carries two wheels, one of which acts as a follower and the other as a driver to the different shafts. The figure shows a compound gear train. Here you can see shaft A and shaft B. In this figure, shaft A and shaft B, these are the intermediate shaft. A shaft A or shaft B whole intermediate shaft. This shaft A carries two wheels, gear number 2 and gear number 3, and shaft B carries two wheels again, gear number 4 and gear number 5. Now for intermediate shaft A, the gear number 2 serves as a driven gear to gear number 1, and gear number 3 serves as a driver gear to gear number 4, which is on the intermediate shaft B. Similarly, gear number 5 serves as a driving gear for gear number 6. So this is the specialty of this gear train. Now you need to find out velocity ratio. We need to find out the velocity ratio. So according to the definition, velocity ratio is n1 by n2 equal to t2 by t1. We know this thing. We have studied velocity ratio. For give it equation number 1. Similarly, velocity ratio for gears 3 and 4 is n3 by n4 equal to t4 by t3. Now here you need to know gear number 1 is in match with gear number 2, so that is why we need to find the velocity ratio of 1 and between these two gears 1 and 2. Now for we need to next time we need to find out the gear velocity ratio between 3 and 4. At 2 and 3 why didn't we find for 2 and 3? Because 2 and 3 are on the same shaft and their velocity will be same. So that is why we need to find the velocity for between 3 and 4. Now between velocity ratio between gears 3 and 4, we have n3 by n4 equal to t4 by t3. Give it equation number 2. Similarly, 4 and 5, their velocity are same, so we'll find the velocity ratio between 5 and 6. So velocity ratio for gears 5 and 6 are n5 by n6, and n5 by n6 is equal to t6 by t5. Give it equation number 3. Now if you multiply all this equation 1, 2 and 3, I will have n1 by n6 equal to t2 by t1 into t4 by t3 into t6 by t5. In other words, we can write it as a velocity ratio product of number of teeth on the drivens divided by product of number of teeth on the drivers. So this is fits our definition of velocity ratio, which we have earlier discussed, that the velocity ratio is equal to speed of the driver divided by speed of driven is equal to product of number of teeth on the driven gears divided by product of number of teeth on the driving gears. So this is the same. Thank you.